All right, so I have a few different things I want to do today. As you all know, assignment 4 was due.
I had a
Yes.
question.
Yep,
Um,
question, yes.
what
Go ahead.
when is assignment 5 coming out?
Tomorrow morning.
Tomorrow
That's
morning?
what I was just going to talk about.
Okay. Also, like how do you know like if I mean uh like how likely are we gonna have to like I mean like what is like the current grade you would need to get to pass, basically what I'm trying to say.
Okay, so well, I don't know, pretty low, but we'll find out in the next 4 days or so. Okay, so what I said about, I think about a month ago, was that I was going to finalize the curve after assignment 4 and the second midterm. And of course, things got changed up a little bit because we actually only have, not all the students are actually doing assignment 4. Some of them are doing the group project, but nonetheless, as soon as we get the grades in for assignment number 4, then and midterm 2, then I'm going to finalize the grade and tell you exactly what you need to do. So assignment 4 should be graded by Sunday, hopefully, or a day or two after that. We'll have all the regrades done for the midterm probably by Saturday. So with any luck, by the end of this weekend, we'll be at this point where we can actually set a final curve. Okay? I assume that's okay.
Yeah, that's yeah, okay. That's fine. Yeah.
Okay, I mean, when I have the curve, I'll also tell you what you actually, have to do to actually pass the course. Hopefully that won't be a problem for anyone. I'm not really, trying to penalize anybody in this sort of difficult time that we're in right now. So hopefully that won't come up. Okay, so yeah, assignment 5 is going to come out tomorrow, and that's going to be kind of interesting. It started out to be much more ambitious than it turned out to be, but I think it's still going to be quite a bit of work, and it'll be kind of cool when we finish with it. So that's going to be cool. And if I have time here, I'll go over that a little bit at the end. But in the meantime, then, what I want to do is go over some new stuff that we haven't talked about before, essentially concurrency. So let me do that. I'm going to share my screen.
Before you start, I have a question.
Yeah, what's up?
I don't know if you've gone over this yet. I joined a little late, but for the demos, if we decided to do the group project for next week, how are we doing that in a Zoom meeting, or are we just going to give you like a video demo and you're going to just
right? I wanted to send a mail out about that, or a Piazza post about that tonight. What I'm going to do is, instead of them being both next week, I'll be able to do some of them on Thursday and some of them on the following Tuesday, the very last day of class, because there aren't that many of you, and probably not all the groups actually want to present. I haven't really totally decided how I want to do this. Ideally, what we'd be able to do is that I would allow you to actually share your screen, and you would talk through your project, you and your buddies, whoever they are. Okay, does that sound reasonable?
Yeah, that sounds good.
Okay, so I'm going to finalize that in the next day or so as well. So what I'll do is I'll send out mail pretty soon about that to all the different groups, and then when we find out which ones are going to be able to or want to present, then we'll figure out exactly how many days we need. But I anticipate probably a few next Thursday and a few the day after that, and that's probably it. What you should be planning, though, is to have a video actually recorded in advance anyway. Number one, just for practice, but number two, that we might have some sort of technical difficulties where we have to, do it non-live, which would be too bad, but we want to be prepared for that if it happens. All right, anything else? Okay, 13 people, excellent. All right, so then what I'm going to do is start talking about multi-threading and concurrency. Okay, can you see my keynote screen? Anyone? Hopefully, yes. Yes.
Yeah,
good.
I can see it. Yeah.
See a thumb. Excellent. Okay. So what I'm going to talk about today is mainly concurrency, and I'm going to talk about that all today and some of next Tuesday as well. And there are several different ways that you can have concurrency in Swift and iOS. And what I'm going to talk about first is what's known as Grand Central Dispatch, which is a way of dividing the work that has to be done onto several different queues, many different queues actually, and those queues can potentially be run on different cores, different processors, so you get a lot of concurrency, a lot of speed up that way. There's also something called URL sessions, which is sort of along the same lines, but it's just sort of a very packaged way of performing long running jobs that are going to take a long time, such as fetching stuff across the network. And then I'll start talking about dispatch groups a little bit, and then a couple other things as well. And then we'll go into sort of more fine-grained concurrency control next time. Okay, so multi-threading, why do we want to do this? Well, this is just like anything else, any other type of system. We want to do multi-threading to handle potentially, for instance, long-running activities that take a long time. We don't want to block anything else, so we want to sort of run them in the background, potentially, you know, on a different low-power processor. Without blocking all the other activities. So we could also do this potentially for computationally expensive stuff. In fact, for the computationally expensive stuff, multi-threading, one of the things you can do, obviously, is divide it and conquer it and put it on different queues. And once we have that, then we can have all the different cores running and making progress towards the same goal, and that's a good thing too. And the way that this is done is through the general umbrella of what's called the Grand Central Dispatch in iOS. And the main abstraction in there are what's called these queues. All right, they have a lot of different queues, but they also have lock-based synchronization, barriers, and some other things that I'll get into pretty soon. All right, so the queues that we're talking about are all called dispatch queues. And there are several different types. There is the main queue, which is a serial queue. That means that the queue is just a sequence of jobs and they're run one after the other. And they never overlap, it's serial. There are also concurrent jobs. The global queues are concurrent jobs. There are any number of global queues you can create, and you create them with different quality of services, such as .user initiated, .background, .utility, etc. Lower priority as we go. These can be either concurrent or serial, but by default, they're going to be concurrent, which means that I can put any number of jobs on a single, say, user initiated or a background queue, and they could potentially all run at the same time, potentially even on different cores, etc. All right, so they shouldn't be sort of doing overlapping computation, because when that happens, then you have potential data races, etc. The main queue is the one where all user interface activity is going to be. So on the main queue, you do everything that has to do with having a very responsive environment for the user. So you don't put anything on it that's long running. You don't put anything on it that's going to block other stuff. You just want them to be all sort of user interface related, because those are the most important things to give a responsive feel to the application. And they should be short. Anything that's not short, you should stick on one of the background queues. If we're talking about user interface activity, we can actually put some of it on the user initiated queue as well. Okay, so the way that you actually use these is you say something along the lines of dispatch.queue, main, and then you provide a closure. And I have examples of this stuff in a few slides. And the same thing with the background ones. So you can add to these background ones with something that looks like this. It's not exactly like this. You can see my mouse, right? Yes, no? Somebody give me a thumb. Excellent. Thank you, Cameron. Okay, so you can add to queues by creating a job and putting it in a closure, and then say a background queue. And this is some queue that you've defined from dispatch.global with a specific QoS level. You say .asynchronous, and that means it's going to stick it on this queue, and it's executed asynchronously, which means that this call returns immediately, even if the job hasn't finished. You can also do this synchronously, which means that you stick this closure of yours on a queue, but then your call to this, adding the queue or adding the task to the queue, doesn't return until the actual job is finished. That's the synchronous and the asynchronous stuff. Okay, so this is just to be sure everybody's on the same page here. Serial versus concurrent. This would be a serial queue. You have a bunch of different tasks. The second task doesn't begin until the first one finishes. Likewise, the third and the second, etc. Whereas in the concurrent queue, it can be anything. You can have multiple queues. You can have all the different tasks running at the same time. They can overlap. And so hopefully they're not accessing the same data, or at least if they are, they better be doing some sort of synchronization. Otherwise, you're going to have problems. Okay. Obviously, this is what you want to do if you have sort of what's called embarrassingly parallel path tasks, which is sort of a staple of high performance computing. If you have embarrassingly parallel tasks That means they have sort of very little communication between them. In fact, almost nothing until they're finished with the tasks themselves. So you can farm out all those tasks entirely in parallel. They run at the same time, they finish at the same time, and they can give all their results back at the same time. That's the sort of goal if you're going to have concurrent queues, et cetera. So I showed briefly synchronous versus asynchronous. This is how these would be called in a little bit more detail. And you can create custom queues, okay? So you can create queues that are custom, that can be serial, call them whatever you want. You can have concurrent queues, et cetera. These are distinct queues in the operating system. Now, there isn't any sort of specific association of cores or processors to these queues. So you can create all the queues that you want. That's not necessarily going to improve the speed or functionality unless you actually have the hardware to map to each all those different queues. But especially if they're serial queues, it's a good way to actually sort of organize jobs that are related to each other to ensure that they don't interfere. So for instance, if I have a bunch of different jobs that are sort of working on the same piece of data, one after the other, I probably want to put them all on a serial queue, which means that I don't have to do any explicit synchronization because one finishes before the next starts. Okay, so with Grand Central Dispatch, you have all these different threads. Hopefully you have faster execution, you have responsiveness. And responsiveness has been shown many, many times to be more important to users than sort of overall throughput. If the interface feels snappy, then people are happy. And so responsiveness is a very important goal. And you also want to be able to optimize the resource consumption too. So this is something that you can do because you have different classes of cores, different classes of CPUs, and some of those are very energy efficient cores, but they run very slowly. So if you have something that has to be finished very quickly, you can't use them. But if you have computationally intensive stuff that is sort of, a background crawl of the web or munch through a whole bunch of different data, for instance, then you can throw that on one of these lower powered cores and do much better energy wise than you would otherwise. Okay, so in a little bit more detail, the queues that we have is the main queue, which is serial. It's for user interface, short, fast jobs. We have 6 global queues of different QoS levels, and then you also have custom queues that you can do other stuff on too. And you can create those custom queues with any combination of various different flags. And I'm not even showing them here. There's so many different things that you can actually specify. It can be very useful. Now, there are things you have to take into account when you're actually using all these queues. One of those things is being careful of retained cycles, reference cycles. So this is an example right here where we have this global queue. We toss a closure onto this queue, and we're referencing self down here. All right, so if the self, your global class, whatever it is, actually has a reference to the queue, and the queue has tasks on it that refer back up to self, then you have a reference cycle. So what you can do is, of course, make these things weak or make these things unowned and solve that sort of problem. You also need to be careful where the queues or where the tasks actually go. So this is just an example of some sort of a task that you're sticking on a queue, and presumably there's a lot of work and data to be munged, et cetera, and then a report is generated. And then you want to tell the user that there are new articles available, new things have appeared, new results. Okay, that is a user interface job. So this thing here is in the background with QoS.utility, which means very low priority, and it's asynchronous. So this is definitely in the background. You have no idea when it's going to finish. But when it does finish, the notification is going to be something on the user interface. And so that's why we actually then dispatch back to the main queue here, okay? So just to be really clear what's going on here, let's say we're in the main queue up here someplace. Somebody presses a button that says generate some reports. What we do is dispatch a task to a background queue to actually do all the computation necessary to generate the reports. And then once we've got it, and we want to tell the user that this stuff is available, then we dispatch a short little task back to the main queue because it's a user interface action. So it has to be on the main queue. And what that does is just say that those new articles are available. Okay, so we're not really going to use queues. This course is getting kind of short in terms of the number of weeks left anyway. But that's not something we're going to get into, but it's something you should be aware of because if you ever do any work in this, it's something that's going to be very important for you to be able to make and efficient system. Okay, so there's something related that I haven't talked about in this class, and it's something last time I talked about very early on, but this time I sort of reoriented or reconfigured the order of all the stuff that I was going to talk about, and I just sort of missed it. And that's this notion of a URL session. And a URL session is sort of comes in as the same sort of thing as what we've talked about. It's basically about trying to offload a long-running computation so that it doesn't block other stuff. And then when that computation is finished, you dispatch back to the main queue to actually say that your job is finished. But a URL session is not this very general purpose mechanism. Instead, it's just for fetching or pushing data to remote locations through URLs. So a URL session creates a session, okay? I mean, that's what it's called, it's a session. And a session is I think the usual canonical example of this is you think of like a tab or a page in your browser, and you have all these different things in that page. You have images, you have text, you have various different objects that are doing things. And each one of those actually has a distinct request, usually sent to the remote site to bring that in. Every one of those, if you have a page that has 100 different thumbnail images on it, you have a distinct URL request for each one of those, HTTP request, okay? All those would probably be in one session. And the advantage of that is that then you can characterize all those requests in sort of one fell swoop. You put them all into a session, and then you say, all right, all the different URLs of this session are going to be this, and they're going to be that. This is sort of like a meta behavior when we were talking about animation, for instance. Okay, so you configure these things with what's called this URL session configuration object. And what that also will configure is caching, cookies, credentials, etc. And then this URL session, once you've configured it, you use to create tasks. And those tasks actually can do things like fetch data to your application. They can upload and download files from remote sites to and from the file system on your phone, or just load images, for instance, or pages from a URL. Okay, so these are sort of the three different things you can do. General purpose data requests, uploading and downloading files, and given a URL, you can just get yourself an image from the other end of it. Okay, so I'm going to show a demo of this. I'm not actually going to program through the whole thing. I'm just going to show a pre-made one, just because it would take more time than it was probably worth. And it's going to have one other thing in there that I haven't mentioned before. And so this is the topic of scroll view coordinates. So if you remember, we talked about scroll views being something that you're going to stick an image on, and the image is quite often much larger than the actual scroll view surface itself. So you can pan around, you can zoom, etc. All right, now it's really convenient, it's really useful to do this sort of thing, but it can be sort of problematic when we actually try to use that. When we try to use the scroll view, because the points in them, if we actually use, for instance, a gesture recognizer, we tap on the scroll view, and then that point is in the context of the scroll view. And we need to sort of translate that into the context of the underlying content, the image itself, which might be much larger. So we translate the coordinates from one system to another system in order to figure out exactly where the tap was with respect to the picture itself. Okay, and I'll show how that's done too. It's very straightforward stuff, but you have to know that it actually exists before you can do it. So I do have this image scroller demo, and the characteristics of this are that, first of all, the picture is going to be in its assets. There is a picture in its assets, like I've shown before. But what it's really trying to show is how to use these URL sessions to actually sort of start a request to load an image from a remote location. And while that's going on, do other stuff. This also, by the way, uses a split screen view controller, something we haven't shown at all so far. I'm not going to go into detail about that at all, but I am going to load this, this demo up on the site, so you can go through it yourself if you want to. All right. So let me do it. Oh, wait, I'm not quite done. Damn it. All right. So this is a little bit more detail what you actually have to do. You have a tap recognizer. You want to say center the screen around. This is what I'm actually going to do in the demo. And you need to convert the tap location from the scroll view context to the underlying image context. And you do it with this bunch of code right here. You look at the recognizer state to make sure it's ended, because, well, you don't want to see multiple different events for a single tap. You just want one of them. We're picking ended here. You get the location recognition, the recog.location in the context of the scroll view here. And then once I have it in this property location, I can convert it into the image view. So I convert into the image view of this location button from the scroll view. So it's converting from scroll view to image view. And then I do the same thing with the bounds of the scroll view. And then what I'm doing with this code down here, I'm not going to go through it with an actual bunch of numbers, but what you're trying to do is, I have this point in the scroll image view, okay? And I need to figure out where that is in terms of the image itself. And so the first thing I have to look at is sort of the offset of the scroll. You know, has it panned to the right, or has it panned down? And so that's what we're doing right here. And then that difference in how far it actually pans and how far it goes to the right and down, et cetera, then has to be scaled by whatever the current zoom scale is. Okay, so both of those mutations happen, and then you can end up with an offset in the scroll view that is equivalent to your desired offset in the image view. So to say this one more time here, we start out with the location in scroll view coordinates. We convert it to the image view coordinates, and then we do the same thing with some bounds of the scroll view. And then what we're trying to do is figure out in the image view how far off is the point from the middle of the current image. And what we're trying to do is center the image around that point. So we look at the difference between the point that we came in with the recognizer and the middle. And then we scale that by the zoom scale, and we change then the scroll view content, and we get it actually centered where it needs to be. Okay, so the last slide right here is, this is for URLs. I just wanted to put this here as sort of a reference when people are looking through this later on. If you have a local image, that is an image that's actually a file in your project, then you can use bundle.main.url for content to actually get that image. If you're going through a remote URL, the canonical way of doing this is by using a URL with an initializer that takes a string, which is the string representation of that URL. Okay, all right, demo. Whoops. Okay, here's the demo. Go away. All right, so this is, again, a split screen view controller here, which means that this is the overall view, and then we can go to a detail view. Now, if I was on the iPad, what it would actually allow you to do is have, say, the left side of the screen be the general view, and then the right side, the majority of the screen, be the detail view. And sometimes, in fact, you can actually even do that on phones if it thinks you're big enough. No. Okay, so there's actually some mechanism in the system that decides whether or not your phone, your display, is big enough to actually show the overview and the detail view at the same time, or whether it has to just show one or the other. Okay, and this phone here in SE, well, of course in SE, definitely couldn't do that. Okay, so what's going on here? All this is that I've got URLs for each of these different things here. I click on one of these and it loads it, all right? So I can zoom, I can pan around. Professor. And I talked about, you know, how to do this sort of zeroing in on a point and doing a conversion. So if I want to center around this right here, well, I can do it, but, you know, I lose some space because the image, I've zoomed out too far. But let's say that I want to zoom around this point here at the top of this little tower.
Yeah, actually, so there's a problem. Like, for some reason, the demo is like, I'm not sure. So we're not seeing anything.
Really? Did you see the slides?
Yeah, we can just see the slides.
Like, I think you need to share. You're sharing just the slides window instead of your desktop.
You're right.
So
you're right. How about that?
That's just the simulator.
Right. That's what I want you to see.
Okay.
You see the picture, right?
Yeah.
Okay. Yeah. I was thinking that I was sharing the entire desktop, but I guess not. All right. So just again, this is the split view. I can zoom in on this. There's some pretty pictures. When I come in deep, you might want to, for instance, center the picture around a specific point, like say the point here in the middle of this heart thing. Okay, and you see that works, right? It's awesome that it works. You might not even think that's very important or very complicated, but in fact, there's a lot of mechanism behind it that actually allows you to do that. So let's show how that works. So I am now going to go over. I have so many windows. Ah, it's the right one. Okay, so now you're seeing button controller here, right? So there's button controller right there. Yes.
No, it says read scene. It's a different Xcode project, I think.
What's button control? Wait. Oh. Okay. Yeah.
Okay, forget this. I'm going to just share my entire screen. Let me know how horrible this is when I do it, because I have 27-inch iMac. All right, can you see the whole screen?
Yeah.
All right.
You can see it. Yeah. It's actually not that bad.
It's not that bad?
Yeah.
Okay, does this go pretty quickly here? Or is it really jerky?
No, it's fine.
It's
You
fine.
should maximize it though, so it makes it a little bigger.
I could do that.
Perfect.
Okay. So then this is the code. Okay. So there's a button controller. Get in there. And there's the photo view controller. All right. Now, if I look in the main storyboard, what this has, and you guys can look through this later on, is basically a navigation controller that is embedding this main controller right here. This is my main controller, and then this is going to be the detail controller, which actually shows the photo. And the way these are connected, the way that I created this, of course, is I just created this view controller, and then I said embed in, right here I said embed in navigation controller, and when that happens, you get this guy here. But then this navigation controller is actually embedded in a split screen controller. That's what this master view controller is. And I'm just not even going to go through that because we don't need to deal with it right now. But the important ones are the button controller, which is this one, and then this one down here, which is the photo view controller. Now, I have created segues from each of these buttons to this photo view controller. And the way that this is done is you just, control drag from a button down here. I'm not going to create another one because I've already got 4 of them. So let's just ignore that. And if I look at each one of these, you can see that, for instance, this first one has an identifier as Moon. The second one is Orion, as you might expect, Earthrise and Falcon. And if I go back into the button controller, you see it's very simple, it doesn't do much. The only thing that it has here is this prepare for segue override. And what it does in there is it looks at the segue, it makes sure that the destination is actually a photo view controller. And then it looks at the identifier, which many of you did on the last test, even though I hadn't really discussed it in class. But it looked at the identifier, in this case, Moon, for instance, and for each one of these, it has a different URL it's going to go fetch. All right, so what it does then is it sets up this property in the photo view controller, .image URL. All right, that's it. It doesn't call a function in there or anything like that. But it's kind of cool because we actually, by writing to this thing, this .image URL, we're actually getting a function called because we have sophisticated stuff going on underneath the hood in Swift. All right, so image URL is in fact a stored property. It's not a computed property, but it has a property observer on it, did set, okay? So this property observer notices when image URL is set, presumably by the prepare for segue from the button controller. And then it comes down here, it creates a session. This is the URL session that we were just talking about in the slides. And then unwraps the result of that into URL and creates a data task within this session where it actually goes across the network and grabs the data. All right, and the closure for this, the actual task that's being done is this. And then this whole task here is going to be on a background task. Okay, whatever task is set up by the URL session, but it's not going to be on the main task. All right, once that happens, eventually it comes into this closure and says, all right, we've got data. And if it is good data, then it wants to notify the user that the data has actually arrived and they can view the image at that point. And the way that that's done is we actually just go ahead and set self.image equal to the image that we just got from across the network. All right. But that is a user interface task. And remember, for user interface tasks, you have to do that not on some background queue. You have to do that on the main queue. So within this task that's running on some sort of background queue, we then have to dispatch another task on the main queue to actually set self.image equal to this image that we just got across the network. All right. And once we've done that, then the image pops up into this main view here, or this main variable. And we have this computed property down here, image, which then will actually set the image view's image to this new value and then size the image view to fit the image that was actually put into it. Okay, so it's actually sort of a very sophisticated thing. It's pretty straightforward to use. This looks a lot bigger than it actually would be normally because we've got all these print statements in it. Let me show you what those print statements do. Okay, you can actually see some of them right there. But let me go back to here and go into one of these guys, Earthrise, and you see these print statements that have come in. Now, what I'm just doing here is printing these things out, these different numbers out at various different times in the course of computing this task. All right, so the 1 happens up at the beginning, of course, before we even create the URL session. The 2 happens inside the actual task that we're passing off to the session data task to be performed. Okay, within that, eventually, this is going to get called when the data is actually arrived back. And at that point, if it's good data, then we dispatch the last task on the main queue. But look at the ordering that we get these through. The first thing that's printed out is number 1, of course. The second one of these lines, which is printed out, is number 7. And the reason for that, of course, is that this is asynchronous. It's completely asynchronous. So this stuff doesn't necessarily happen right away. In fact, it generally doesn't. Unless we have a huge number of cores and it looks like it's going to be an expensive job, it's just going to, the task URL session is just going to stick it on a queue and execute it whenever it has time on the current queue, in many cases. So in fact, what happens is we run this line, we run this line, we run this line, we create the task, and then we just keep going down here. Task.resume is what actually says run this thing. So that's another reason, I guess I should have mentioned that. That's another reason why this doesn't get run before the 7 here, is because resume is what actually tells the session to actually run this task. But it's not going to necessarily run it at that point. It could run it much later, right? It just says, it's just basically don't run it until we get a resume here. So we print out 7, then we print out 8, and then eventually we print out 2, which means that this task has finished. And it immediately will print out 3 because this is still the same closure, the same task. But then it dispatches back to the main queue, which could happen potentially at a much later time, but you can't really tell from when these things are printed out because I don't have times. So you get 4 and 5. Okay, so it's useful looking at an example like this, I think, just to get a sort of very visceral sense of how these asynchronous workflows actually happen. We've got the main workflow where we have something that's driven by the interface that creates this background task that fetches the data across the network. And when that's finished, that creates another asynchronous task that actually updates the user interface. Okay, then the other thing that I wanted to show in this is just where the tap stuff is. Now, I already showed it on the slides, but this is the tap recognizer here. Okay, it's exactly what's in the slides. It's just converting the new points that come in from the scroll view into the image view, and then creating an offset for the scroller based on how far the point is from the middle, because what we're trying to do is center the picture where the user tapped. So the offset that we want is going to be from the point itself to the middle, to the current middle, but then that has to be scaled by what the zoom scale is. Okay, and that's basically it. All right, let me go back. Okay, you can see Keynote again, hopefully. Yes, no? Someone give me a thumbs up.
Yes.
Good enough, thank you. Okay, so that was queues, and I've talked about the session URLs, URL sessions, which is sort of related. Another way that you get concurrency, potentially in a more fine-grained way, is through this thing called dispatch groups. And I lost my mouse on a different screen. And the dispatch group allows you to have a group of different tasks and get some sort of global information about what actually happened. So the example here is I create a dispatch group, and then I farm off some tasks asynchronously on, whoops, on some queue here, another one on some queue, another one on another queue. But they all have the same group specified when it's actually thrown off. Is there a question? No? Okay. So I've created these 3 different tasks on 2 different groups. They're all part of the same group. And then I can set up a notification for when they're all finished. Or I can do this. I can say if group.wait.now, group.wait until a timeout happens 60 seconds from now. And if that happens and that group has not finished, then this closure gets triggered and I can actually print things out. So this is just a way of dividing up the computation into a bunch of different tasks, throwing them out there and finding out when they're all finished. Okay, it's a very important task to be done. Okay, I can't see what's at the bottom. Let me see, asynchronous notification of completion, can add more tasks until none outstanding. Yeah, so I mean, even at any point, we can add more tasks to this group until they're all done. And at that point, you can't add any more. All right, so just a quick demo of this. I don't want simulator. Don't want this. Yeah, that was the one. Okay, so this is just a playground showing an example of this, the dispatch groups here. All right, so I've defined a group called group. I have a queue that I have named. It's just a global queue, user interactive. And then what I do is I send off a task here asynchronously with this group, do the same thing for a second one. And then I have a timeout here. Or I get notified that we've actually had them all completed. And if you notice what the tasks are doing, one of them is twice as much work as the other one, right? This one sleeps for 1 second and this one sleeps for 2 seconds. So hopefully what I'll see is that this one finishes first, this one finishes second, and only then am I actually going to get the printout all jobs done. And hopefully both of them happen before the 5 seconds have elapsed. So I run it. Nothing happens. Oh, shoot. Okay, it seems to be running now. It's just slow. It's just real slow. All right, let me try again. All right, start one, end two. Okay, yeah, so it did exactly what we expected, all right? Nothing very exciting about this, but this is something that you can actually use to do synchronization of tasks you're throwing all over to different queues. Very useful thing to know how to do, have in sort of your bag of tricks. Okay, demo, all right. So semaphores, we also have semaphores. All right, you've used semaphores in a lot of other languages and other classes before. They're really quite useful. And the context that I want to show them here in is using them to sort of throttle access to a specific amount. All right, so assume we're downloading a lot of data from the network. We can use dispatch queues to offload work, but what if we only want 4 simultaneous downloads? All right, we don't want to have potentially too much actually going on, or too much bandwidth being consumed by these background tasks, because we might have foreground tasks that need bandwidth as well. All right, so we have 10 groups maybe. We don't want all 10 of them downloading at the same time. We only want 4 simultaneous downloads. So how do you do this? Well, with semaphores you can use to do all sorts of different things, including to guard critical sections, etc. But they can also be used to reserve resources. And that's what we're going to do with this one. So, all right, here we are. All right, so we have a dispatch group again, and the queue that we're going to use is a global user interactive one. And we're going to have a semaphore with a value of 4. Okay, and that semaphore is just going to be used to, again, limit how many of these tasks can be run in parallel. So what I'm going to do here is I'm going to farm off 10 tasks very quickly. And each one of these is going to be doing some sort of computation that's going to take 3 seconds. I don't want them all to work at the same time. So what I should see when I run this is that 4 of them start up, and then those 4 finish, and then another 4 can grab the semaphores and start up, etc. We're running 1 through 4, 5 through 8, and then 9 and 10. Okay, so using semaphores in a straightforward way to do reservations of bandwidth. All right, you've done this in other courses as well, and we don't always necessarily need to get this low level in iOS, because there are a lot of high level mechanisms that can do this stuff for you. But when you need to do it, it's there. All right, the last thing I want to talk about a little bit is race conditions. And the sort of canonical example for race conditions is doing an increment, for instance, of an integer. So you have some sort of thing called count. You want to do plus equals 1. The problem is when you don't have synchronization and you have concurrent access, simultaneous access, you can have 2 different threads doing this at the same time. They can each do a read. They get the value 1. And then thread 1 can write back 2. And then thread 2 can do the plus 1 locally from the read of 1 that they already got earlier, and also get 2 and then write it back. All right, so we have 2 different increments of the value of 1 initially, and we should have a final result of 3. Instead, we get a final result of 2. And these are always very difficult to debug. You don't want to have them happen in the first place, because debugging, they're called these Heisenbugs, because sometimes they happen, sometimes they don't. And it depends on whether you're looking at them when you actually set breakpoints, et cetera, to look at them. Sometimes you disturb the timing to the extent that the bug doesn't actually occur. All right, so there are a lot of different ways you can do that. One of the canonical ways to do it in iOS is to use a serial queue. All right, so we have concurrent queues. All the global queues by default are concurrent. The main queue is always going to be serial. All right, so that means that if we have different tasks that we want to be completely distinct, if we throw them all on the main queue, they're going to get executed one after the other. There might be other things in between those, but they're never going to be executed in an overlapping fashion. So if I have this function that does an increment, that uses an in-out variable, so it actually modifies this. So I say increment ampersand count, and if this is done in both 2 different threads at the exact same time, excuse me, all that's going to happen is that each of those increments, each of those threads is going to get a task stuck onto the same queue. And that queue being a serial queue means that, in fact, it doesn't say serial here, it should say serial. Okay, so I'm not gonna change the actual calling sequence there, but if this is a serial queue, then it doesn't matter how these things are actually stuck onto the queue. Only one of them will be executed at a time, and because of that, then you're not going to have any sort of race condition. All right. Then we're also there's another thing called a dispatch barrier, which I've personally never used, but the idea here is that we have concurrent queues. And concurrent queues can do lots of different things at the same time. And that's because they can sometimes do time slicing between different tasks. Sometimes they use multiple cores to execute tasks on a single queue, etc. All right, but with those concurrent queues, we can have special tasks that are called barrier tasks. And you set those up by just setting the flag .barrier when you actually enqueue the task that you want. And when that happens, that means that that task has to be executed completely alone. It can't overlap anything else on the queue. So if these tasks come along first, and then this task is actually the increment here, I know it says right, but it's really supposed to mean the increment, then this increment task can't start until all those previous tasks are finished. And then nothing else can start until this task is finished. And if I have this increment here by thread 1, and thread 2 comes along, has its own increment task, that might be the very next thing executed. These are not going to be overlapped in time at all, which means that there isn't going to be a barrier, there isn't going to be a data race. And then likewise, none of the tasks coming afterwards can actually be started until that second increment is done. So this increment is going to be completely safe. Even though it's executed without sort of explicit synchronization here and on a concurrent queue. And the reason for that is this flag makes that concurrent queue temporarily act like a serial queue just for these tasks. Okay, yeah, that's it. And this is the increment. Okay. And that's about as far as I want to get in this today. I'm going to come back and talk about some more mechanisms. On Tuesday that will let us do that stuff. What I want to talk about a little today is then project number 5. So there we go. Project number 5 is going to be, go away, something called Talk. All right, so blame Linda Young for this. She's the one who suggested it. She said I should look at TikTok. Okay, so the idea here is we want to do something in a very scaled down way that is similar to what TikTok has, in the sense that it allows folks to upload videos, and those videos can then be voted on, liked, whatever you want to call it, by multiple different folks. And then we can use that to actually, we have a chat. Is there a question? You can't see? No, you can see. Oh, I see. All right. So again, this is going to be a very scaled down version of TikTok. And I got to say that this was going to be a lot more ambitious, but it turns out that doing authentication is a very difficult thing to do. And trying to get something set up for all of us to do authenticating to the same database in Firebase was going to be something that I think that was just going to be an unholy mess. So we're not going to do that. So what we're going to use is Firebase as the backing database, but we're going to use it in a completely unauthenticated way. All right, so what you're going to be doing is setting up a very simple app, and this is something I put together in one day, so it's really ugly, I gotta admit. And it's going to let you do essentially 2 things. This recorded video down here does nothing. It's going to let you upload URLs, because I don't want you to actually upload images, videos, because you have a limited amount of space in the free Firebase accounts, the Spark accounts. So because of that, what you're going to do is upload URLs for videos that you have elsewhere. All right, and I have a few that are set up on my servers, and you can set some more up on your own servers and upload URLs, etc. Now, this is the console of the real-time database. And this is essentially just a big JSON tree. All right, and here I'm showing 3 different videos. One about Neo, one about sheep, and one about a sunset, and here's the URL for it. And what else? This one about Neo actually has a like to it, okay? So just like TikTok, you're gonna wanna have, essentially, you're gonna generate a playlist of the videos, and that playlist is gonna consist of all the new videos that you haven't seen sort of at the top of the list. And then below that, you're going to want to sort videos by the number of likes, because those are the ones that are liked are probably the ones that are going to be, that you want to see more than the ones below that. And you're going to use these likes over here on the database to do that sort of sorting elsewise. You're also going to use the database to figure out which ones you've seen or not, and I'll show you how that works. All right, now I'm going to hit play videos, and what it's going to do is it's going to create a playlist, and it's going to start playing one. It's probably going to show Neo first. And when it does that, it's going to generate a scene datum in the database here saying that it's actually seen this video. Okay, so there it goes. I gotta get rid of that. Okay, here comes Neo. And I'm going to like it by clicking this hand. And nothing changes over here in terms of the likes, because when you're creating the likes, what I'm having you do is actually just create a like underneath whatever image or whatever video that you're on that has a key of your name, okay? So no matter how many times I like it, it's just gonna override Kelleher here. And if you other 13 or 14 of you there actually go on this and like it as well, then you're gonna have other likes down here, and we'll have 13 or 14 total likes. Go away. 13 or 14 likes for the entire thing, okay? And now you can see that I've seen all 3 of these different videos. When you upload a URL, what happens is you want to create a unique child in this JSON tree. So this is, it actually talks about it in the document, how you create this thing. You create this dynamically created child ID, which is guaranteed to be unique, even if you have concurrent access at the same time. And underneath that, you put the name, you put the URL, and you put the likes. All right, so for upload URL here, you can upload new stuff. So for instance, I can say horses, and I can enter HTTPS, where's this? All right, so I've created a new one, and we should see that pop up over here in real time when I hit the upload button. Boom, there it is. Horses, and here it is. And if I come down to play videos now, it didn't actually put it first because it was probably in the middle of a playlist. There's the sunset, and here are the horses. Okay, and now I've seen that one as well. All right, so there are other things that we can do. Right down here, I have a record video. It doesn't actually record video right now, and you don't have to do that for the project. That would be an extra credit point. All right, so for the project, I have 100 points defined, and there's quite a bit of work to do those 100 different points. But you can actually get extra credit for the final exam. Again, just like the last project, there are 2 ways to do that. One of the ways is to actually record video on your phone. It has to be on the phone, not on the simulator, and upload it someplace, and then upload the URL. Okay, I would recommend, if you're going to do this, unless you have your own server that you can actually put the stuff on like I do, that the easiest place to upload a video that you create is actually going to be on Firebase storage. All right, that's just another service that they offer. You have to be kind of careful because you have in your free membership, you only get 1 gigabyte per month download. So you want to make those videos small. All right, the other way you get the extra credit points is to take existing videos and transmogrify them somehow, add text over them, etc. Something along those lines. And this project, you're going to start out by just doing exactly what I have here, where I have my own personal database. No one else is on it, so I completely control it, and I can debug my code and everything. But then the cool part, hopefully, will be at the end when everybody can actually start using the same database. And so then this thing goes live, and hopefully we've got a bunch of URLs uploaded by different people, and you can actually start getting lots of different likes for different videos, and it gets a lot more fun at that point, I would hope. Okay. All right. Are there any questions about this or anything else that's going on in the class right now?
What are the final deliverables for the group project?
The final deliverables will be, I probably should specify that in more detail, I guess you're right. They're going to be a video showing, demonstrating your project, hopefully a presentation in class, and a small document describing what you've done, the challenges that you faced, and the mechanisms that you used to get past. Okay, so none of it's going to be, except doing the demo itself, none of them are going to be very, very difficult. But then the other deliverable, of course, is the actual code, because we're going to go through the code too.
When are the deliverables due?
The 10th is what the
The
schedule
10th
says.
is when everything's due. Now, you know, I'm going to be kind of loose about that. Everything's messed up this semester. It's been, you know, very, very difficult. But ideally, everything is going to be due on the 10th. Project 5, for those that aren't doing the group project, isn't going to be due until the 17th. So, you know, it's, if the group project, if you go over the 10th by a few days, it doesn't matter, right? I mean, you're not going to be going past what the other folks are doing anyway. And the actual final for this class is not till the 20th. So we have time. So I don't want people to get too worried about time pressure at this point.
I had a question about like is this project 5, is there going to be like something that we can like follow along to, like are you going to make a video similar to how you did with like circles and like the other?
Yeah, I'll do that before I actually release it tomorrow.
Okay.
And we have already quite a bit of work on it. Let me see here. Okay, so this is a relatively final version of the assignment itself. And it goes through it step by step, saying all the various different things that you have to do, how you have to set up rules for accesses on Firebase, etc. And I try to put in pictures where it's useful to show what's actually happening, how to lay out your storyboard, how to do the various different controllers, meditation sheep, how to write to the database. And I have links in here for more detailed information on Firebase and the other sites themselves. And then I talk about step 5, which is how we go live on a shared database, which could be kind of cool, or it could be another utter mess. I don't know. And we've already got complete grading already specified. So the only thing that has to be added to this is basically the video. And I need to get feedback from a couple more TAs. And then hopefully sometime tomorrow, this will be released and you'll have 17 days to do it. Okay, anything else? No? All right, thanks for coming, and I'll see you guys Tuesday.